about Kaapana, which is an open source federated AI platform for radiology. It is developed by the Division of Medical Image Computing at DKFZ. First, I would like to start with some motivation. As everybody here, I believe knows that the AI and imaging has explored in recent years. Prime example is the ImageNet that is considered, like image classification is considered a solved problem. And another challenge, for example, object detection on COCO dataset is also improving quite fast. And what is really nice to see is that the models from there are directly translated into products in real life. And the question then is like, there are also medical AI datasets in research. For example, BRAS challenge that was already mentioned here, or VERSE challenge about the segmentation of vertebrae in the scans. So why is it not really why we cannot find these research models or papers in a clinical practice so often? And there are multiple of reasons. Some of them are already mentioned here. For example, generalization gap between research and clinical practice. So we know that if we train the data on one type of data and then try it on the other one, it probably won't work. And that's mostly what is also happening, that different types of problems, like for example, different scanners, different imaging protocols, or anatomical regions are models are trained on and then tested on. And that, of course, creates a huge performance gap, which is also kind of caused by data accessibility. We have various problems with accessing the data, whether it is private, like regulations like HIPAA or GDPR prevents us from easy collaboration and sharing the data, or it's limited annotation, because annotations in general imaging are easy to create, or at least easier to create than when expert opinion is needed. And one of the another challenges is that the data is fragmented. It's fragmented over the different medical institutions and centers. So even if we had the possibility to access it, it would be quite organizational hassle to do so. These are not the only challenges. We also have technical and organizational hurdles. For example, when we want different organizations store the data in a different way. Also, the multiple models they are quite different. So if we deploy one AI model in a way and then in a different way, it's hard to unify it, make it reproducible and robust. And it also is part of the last point, that we basically need better standardization of algorithms and models to integrate them into clinics and to make collaboration between clinics much easier. And that's where I would like to introduce Kaapana, which is a platform tackling these practical medical imaging problems. It's an open source technology, so it's free to use for everybody that wants to. It supports clinical communication standards like DICOM, for example, and it's easy to access and use. And by easy to access and use, I would like to mention that it's basically a server-based platform. That means that you don't have to, as an institution, install it on several computers. The idea is more that you install it on a server of that institution, and then the other users could connect to it using a simple browser from their personal computers. Yes. We also try to change the paradigm of model training, or we use a different paradigm of data training that's usually used. Usually what people do when you want to train, for example, a foundational model, they collect a lot of data in one central database or site. But that's of course not often possible, as I already mentioned, because of the regulations or not entirely trusting the collector. But in our example, we try to distribute the models to be trained in different institutions on their server, on their Kaapana instances, and then return the weights of the model and that ensures that the data always stays in the institutions itself. It never moves out of there. But the model basically has all the information that has been trained on this collection of data. Yes, so as I already mentioned, we of course have a possibility to connect multiple instances of Kaapana together. So if one institution installs Kaapana and another one, and they decide to connect them together, it's not a problem. It's easy to do, and then they can communicate, share the tasks, share the data in a federated way, but also in a simple copy way if permitted. Except of these big use cases, of course, as a medical platform, we have day-to-day use cases as well. First, of course, we want to access the data or like put it on the platform. We have multiple ways of doing that. Of course, we can communicate with external PACS system that store DICOM data, but we also have local PACS system that you can upload your data to. And we also have a object store, basically S3 bucket storage from like S3 bucket storage. So basically any data can be uploaded there, text, PDFs, images. It's basically a file system. So it's not limited by anything. Yeah. Then we want to curate and annotate this data. For that, we have a interface to do so, and also organizational structure, so you can organize and exclude, delete, and do whatever with your data that you actually need. After you do all of that, you probably want to run some model or method. This can be either model training, or it can be model inference, it can be pre-processing, or any other method that you want to use on your data. It can be also statistics, it can be just analysis of a table, basically anything. And at the end, you want to retrieve and share results. This can be done also in multiple ways. It can be either putting the data back to the local PACS or external PACS, if it's a segmentation, for example, like a DICOM file, or it can be creating a PDF report and show it, or an HTML report and show it in a Kaapana, or just download it. Yes. As I maybe already mentioned, there are some tools and methods in Kaapana, and some of them are included by default if you install the default configuration of the platform. Some of these tools are for very good for like exploring, like MITK 3D Slicer. Some of them are also good for analysis using Python code. So for example, JupyterLab and VS Code. And we also include some methods, for example, in segmentation, NNUnit, NN detection. We already heard about Total Segmentator, shape models. We also support radiomics feature computation. For example, one specific is MITK phenotyping or radiomics. And we also support body part regression. These are just few that we support. It's not hard to implement your own method if you have something that you want to use and share across the multiple institutions. It's not so hard to do. And we try to stay on the novel side of things, so we also implement new things when they come. And now I would like to show some demo. So I have a platform here installed. As you can see, this is more of an admin view for the maintainer of the platform, because somebody has to take care, and now they can see what's the utilization of the platform, if it's used, and if it may be under the load or not. You can also see general statistics, nothing very fancy. Then you can, of course, upload the data, as I mentioned, and you can upload it either using DICOM Send Standard or just drag and drop with the images. You can explore your data. You can explore it in many ways. You can filter using manufacturer modality. You can create your own tags, which you want to exclude some data or include some data. You can just create a tag, and in a very intuitive way, select it and create a tag the data set. After you created the tag data set, you can use it to search the data, having only your data set. In any way you select the data, there are multiple ways to do it, and then you can start your workflow. This workflow can be anything from simple collection of data, doing a train test split to total segmentator inference. And then if the workflow executed, you can later see the progress of the workflow and also the results at the end. If they are, for example, segmentation, it will appear something like here. And one more interesting feature, you can always get a better look at your images using OHIF viewer, integrated OHIF viewer. The image was loading, sorry. Where, yeah, basically everything OHIF supports, we support as well in these regards. As we already ran some workflows, we can see their status, they are finished, failed, pending, or scheduled. And at the end, we may create some HTML report, for example, like we will see here, that we have a validation report to see what's wrong with our DICOM. For example, this is the DICOM metadata mostly. Yeah. Next interesting part will be probably instance overview, where we can see either some statistics about our instance, but also here we can connect to the remote instances in the different institutions. This also should be probably done by some maintainer. Yes. If we start some applications like 3D Slicer or MITK, we can access them through active applications. We also support OHIF in its natural form, not only in the small window. And there are many more functions for maintainers to adjust projects and series that belongs to projects, to have some monitoring, to have local packs, see networking, see user management, and other things. And maybe the most important thing is extensions, where all these algorithms, like for example, total segmentator, can be developed and merged into our repository, where we can then use them, and everybody can use them by one single install and uninstall. Simple as well. And we support, of course, federated and normal workflows as well. Yes. I would like to come back to the presentation. Yeah, I would like to thanks all the partners of the Kaapana and all the projects that Kaapana is involved in. You can see the map there, and also the team of medical image computing at DKFZ. Yes, if you have any question, feel free to ask.